Okay, 6:05, not waiting any longer. Thank you everyone for being here on time. It's great to see a bunch of people in this room rather than like 2 people, which always makes this more difficult. If you haven't already signed in, please make sure to sign in on the link tree. It should be the very top link. And also, while we're going through announcements here, this would be a good time to make sure that you have Golang installed. If you open your terminal and just type Go, it should give you a listing of all of the options you can use. That's how you know that it worked. If you need help, you can raise your hand, but we're going to jump straight into things right after this. So definitely do that right now. A couple of announcements first. Tomorrow, on Friday, from 7 to 10 p.m., we're going to have a game night social, which is really just a fancy way of saying get all of the stuff in my closet out of my closet. Definitely bring some games, bring some snacks if you want to. You can come for as much or as little as you want, but if you were a member last year and you haven't picked up your club shirt, we will have all the club shirts there to pick up. If you would like a Night Hack shirt from 2 years ago, we will have 2 boxes of those. It's a fundraiser for our hackathon this year, so you can purchase a shirt for $5. Or if I've contacted you specifically about hackathon swag from last year, you can also come pick it up during this time. So please, please, please help me clear out my closet. I literally have no more space. You guys are also setting a bad example. Okay. Couple of other things. We have a couple of positions open here. We have a design team co-director. If you're interested in graphic design, have some experience with Adobe or Illustrator, we really need some help on our design team. You can apply for that on the link tree as well. You'll be in charge of creating literally all of the assets that we use for marketing, for the event itself. Your stamp will literally be all over the hackathon. So this would be a great opportunity if you're interested in that. We also have a data team that applications as of this week are open, so you can apply for that on our link tree as well. No prior experience with data science is required, but if it's something that's interesting you, I highly encourage everyone to participate. As usual, we have the cave every Thursday from 4:30 to 5:50, so you can come straight over here afterwards, which I assume is what you guys did.
Yeah, we went to signature first though.
Okay. And then we also have a new operations meeting time. Previously, it's been Wednesdays at 8:30 p.m., 8:30 to 9:30. We're changing it to Thursdays at 8 p.m. So that'll also be following this workshop. If you're interested in joining that, link will be in the link tree. But I don't think I enabled it, so I'm gonna have to remember to do that afterwards. Okay, that is everything in way of announcements here. So with that being said, we are going to jump straight into the actual work that we're going to be doing here. So give me 1 second to go ahead and create a new workspace here. So we're going to okay. So I'm going to go ahead and create a new folder here. Essentially, what we're going to do today is we're just going to explore all the weird things about Golang, some really good, some kind of interesting design decisions. And in the very end, we're going to try and apply it to create a couple of basic routes. So we have a little API server that we can run on our computer. And there's going to be so many things that we're going to skip over because literally I have a limited amount of time here. So if there's something that is really important to know, I might mention it in passing. There might be things that I don't talk about at all. The goal here is just to cover as much as possible to get you started, and there will be lots and lots of opportunities for research afterwards. Okay, so with that all being said, I'm going to go ahead and open up my new workspace, find somewhere on your computer to go ahead and create a new project. Does not matter where. Yes, I trust myself. And first thing we're going to do is we're going to open a terminal session, which I can do through the VS Code here, or you can open your own terminal. And if you go ahead and type in Go here, you should get a lot of instructions about Go commands that you can use. If you get an error saying that Go does not exist, then you did not install it properly. And you should definitely take some time to do that. But if you do have Go installed, all we have to do at this point is go mod init. Can I zoom in here? Okay, make this a little bit bigger. We're going to go mod init, and then we're going to call this whatever we want. We'll call this we'll call this workshop. So essentially what we're doing is we're creating a new Go module. And our Go module is a bundle of code that we can import into other modules. It's just a unit of code, more or less. We're going to go ahead and just use one singular module here, just because it gets a little bit complicated trying to manage the file structure if we don't. But once we have our Go module initialized here, we are ready to go ahead and create some new code, import some things, and be all good. We're going to start with a main file here. And the file extension for anything related to Go is just .go. First thing we need to do is we need to declare what package we're in. We just created a workshop package or a module. Yes, that's a good idea. Lights. Okay, more light, less light. Is that good for you guys in the back that are in the light? Okay. Let me know if you need me to change anything. I can zoom in a little further as well as needed. Okay, so all we've done so far is we have run go mod init with our module, and we are saying that we are working in the workshops module here. And this is going to look really familiar to anyone who's already done any programming in their lives, but we are going to go ahead and create a main function where everything can get started. Sorry, I thought I saw someone raising their hand. So as usual, we can only have one main function per module. So we're going to go ahead and leave this here, and we're going to work in other files, but just call functions from our main function here, since we can't create multiple in the same module. And let's go ahead and just do something really basic here to let us validate that we can run this no problem. We are going to go ahead and print, we'll do hello world, just for the memes. All right, so we're going to print hello world. And the way that we do that in Golang is using the format module, or I don't know exactly what the terminology here is, but this is not declared by default. We have to go ahead and import formats. So I can go ahead and do that through VS Code because VS Code is super helpful, but otherwise you can just import format just like that, and that'll work the exact same way. And as usual, we're going to print with a line break at the end. There's a couple of different ways that we could print here. We could just go ahead and print with no line break. We'll go ahead and try that. And we can also do format.printf. So those of you who already done a bunch of C, this is going to look very familiar. We can create a string and then print whatever we want in here as part of the format. %d meaning we're going to print an integer, and then we just have to put whatever integer we want here. We'll print 3. Okay, so we have just some basic print statements in here. Let's go ahead and make sure this works. We're going to reopen the terminal here. And what we can do in order to run our code is we can go run main.go. Nope, we cannot do that. Package is not a main package. Did I already? Okay, I confused packages and modules. All right, this is already turning out really great. So we're going to go ahead and make sure that we're in the main package here. And once we hit go run, it's going to go ahead and run all the code in here. It looks for the main function to go ahead and get started. And we can see that we can print 3. This one does not have a line break at the end, but we just don't notice because it's at the end of the terminal. Okay, super cool stuff. So a couple things you might notice here. This is not like Java where functions have to be attached to an object. We can use the function, the func keyword in order to create a new function. We can name it whatever we want. We can give it parameters. We can give it return values. We'll go ahead and talk about all of that in a little bit, but I want to hold that for a little while. Okay, so now we're going to jump into some of the actual quirks of Golang. The goal here is just to get you comfortable with the syntax before we actually start making something interesting. And the first thing to talk about is variables, because even declaring a variable has to be weird. You might, in most languages, go ahead and start with your data type here, and then the name of the variable, and then assign it some value. But we can't do that here. Golang has decided that data types are going to come after the name of our variable. So we can declare in 2 ways. We can declare that we are making a variable, and then we can name it. We'll call this Bob, And then we can say that it's going to be a string. And then we can go ahead and assign it a value like Bob. And this is perfectly valid. You'll notice there's a red squiggle here, which normally you would think is something bad. And it is bad. It's that we are not using this. Our Go compiler here is not going to let us declare anything that is not used. So we can go ahead and print out Bob here. And that will go ahead and take our squiggle away. And that'll let us compile it if we go run. We print Bob. But this is really verbose and kind of weird. So another thing that we can do to make this a little bit simpler is we can create another name here, Phil, and we can use some syntax that prevents us from having to declare the type and the variable keyword. So if we use a colon and then an equal sign, it will go ahead and infer the type based on what we're assigning to it. And that type, you know, it's not like Python where you can change the type. That type is consistent. If I tried to take Phil and assign it 3 here, it's not going to like that. It has to be a string. All right. So let's go ahead and print both of these. What else do we have in here? So we've already gone and printed a couple things. We can also take some inputs. Let's go ahead and take in someone's name. And the way we're going to do that is we're going to declare a variable and not initialize it to anything quite yet. We'll call this user name, and we'll make this a string. And there's no semicolon, so we can just go ahead and break the line here. And we're going to go ahead and scan into our username and let the user, you know, type whatever they want. So the way we're going to do that is we're going to use format.scan. And this takes a variable number of arguments. You can scan in multiple things at one time. You can scan in exactly one thing at a time. And the thing that we have to specify in here is a, does it say in the description? No, it doesn't. But essentially what we're going to do here is we're going to specify the reference to the variable where we want to put it in here. Is everyone here at least familiar with the idea of pointers? Is anyone here early enough that they do not even know what a pointer is in their CS career? Okay. A little bit? Okay, so essentially what we're saying here is we need to get this variable is stored somewhere in memory, and we need to tell it what variable we want to assign our input to. And so we're going to grab the reference using this ampersand, the reference to the username variable. And whatever we scan in here is going to go into that. So we can go ahead and print this out here just to prove that it worked. We'll go ahead and print line. And actually, let's put another print up here just to prompt the user what we want them to do. And now we can go back down and go ahead and run this. So it's going to print Bob and Phil, and it's going to give us a chance to put in our own name. And it's just going to print it right back out to us, which is not super useful. But if you want to take user input, you definitely can do this. Let's see what happens if we try and put in something that's not a string. It's not going to have a problem with that. Let's see if we change this to an integer and then try to type in something, what's going to happen here. All right, so it's not going to go ahead and assign anything since it scans in a string and we're trying to put it to an int. And so this is going to stay at 0. It doesn't actually throw an error here, which is kind of useful. And the reason why it doesn't throw an error is because error handling in Golang is also kind of weird. This is like a good weird though. I think it's a very interesting way of handling errors. So I'm going to hover over this scan function here, and you'll notice in our declaration here, we have the function keyword. We have our scan. It tells us how many inputs we can have, which can be any number of any type. And then it has what looks like multiple return types. You can return multiple things from one function in Golang. And so the things that are in here, if we hover over, is an integer n. So this integer n, no, they are completely separate entities, and you can assign them into separate variables. So the first integer is how many things it successfully scanned. Again, it did not successfully scan that string that we tried to put into an integer. But it also has a second type, which is an error type. And our error type is how we handle our errors in Golang. We can pass errors back to the caller. They can determine what to do with it. We're not like catching it per se, but what we're going to check when it comes back is if the error is null, it means that it didn't have any problem. And if it is null, then it did have a problem and we need to do something with it. So let's try and do this here. Let's leave it as an integer, which is going to fail. And let's assign both of the things that come back to a value. So we're going to say n and error, and then we're going to assign the things here. So the first thing, the first thing it returns comes first, and then you can separate them with commas, and they go to separate variables. We are declaring a new variable n and a new variable error, and they are automatically going to be given the type of whatever is returned here. So let's go ahead and print this just to see what happens. We'll go ahead and run this again. Okay, so what we get back is n is 0, which means it did not successfully scan this. And also this error type is easily converted into a string when you're printing, and we can tell exactly what the error is. It expected an integer and it didn't get one. So it's not going to crash your program. It'll just go on like nothing ever happened, and it's up to you to figure out how you're going to error handle. If we want to check whether this error actually came back as a value, we can check if error is not equal to nil. This is also jumping ahead in my plan a little bit. So I'm really doing a good job of following this agenda. But we can use an if statement. If statements and for loops in Golang do not require parentheses. And if you put parentheses in there, it won't break it, but the compiler will tell you to remove them. So we can check if the error is not equal to nil. Nil is the equivalent of null here. And if error is not equal to null, it means that it gave something back. We can print that we had a catastrophic failure. And then we can append our error. So if we want to get the string value, we can call the error function, and it's going to return the string. And let's go ahead and try this one more time. Very cool. Catastrophic failure, expected integer. Okay. You know how to handle errors, and we'll go ahead and show how to declare functions where we return multiple things in a little bit, but there's a bunch of other things first that are more important. Okay, so with that being said, we have a lot of really interesting structures in place. Let's do one more cool thing with if statements that you can do in Golang and not anywhere else while we're here. So let's say that we don't care about handling this error, but we only want to do something if we don't get an error back. Maybe we're using it for some kind of processing, and if we try and process it when there is an error, it's not going to be the right value. So we can do this two ways. We can go ahead and scan everything in, declare the variables, check if it's not equal to null, output our thing, and then continue on our merry way. Or we can actually do this all in one line here. This is another interesting little thing you can do. So what we're going to do is we're going to do an if statement that essentially has two parts. The first part of your if is just performing one line of code that maybe like scans something in or performs a computation and assigns it to something. In this case, our first section here is going to be performing our scan and getting back our error and our n. We can add a second part to this if statement, which is the actual condition that evaluates after that first thing happens. So after we assign to this error value and our n, we can check if error is equal to nil, and then successfully say it works. And so this is one line where it was two lines previously. And you'll notice that we're getting a red squiggle here because we're not using n for anything. We don't actually care in our case what gets put in here for n. So another interesting thing is the Golang compiler will require you to replace anything that you're not using with an underscore. And the underscore tells the compiler that it's not being used for anything, and it'll leave you alone. We can't just get rid of this entirely. We'll have a red line here saying that it's looking to initialize one variable, but two are returned. So we have to keep something here, but we can just go ahead and use our underscore. Weirdly, though, if it's the other way around, never mind, it's not weird. I was thinking that if it was the other way around, then you wouldn't have to use an underscore, but you do have either way. Okay, so let's go ahead and run this, make sure that this worked. It's incredibly weird. I totally agree with you. There's a lot of cool things and a lot of things that I wish that Golang did that they've decided are just not worth supporting.
Like that if is basically like if you have like a ternary and then you have like a true and a false.
There's no ternary operator in Golang. So this is basically your replacement, which is one thing that I really don't like sometimes. It does come up more often than I like. Okay, so I'm going to change this back to a string here so that we can see that actually worked. In this case, we did get an error back because it couldn't scan it into an integer, which means that this code inside did not execute. But if we do this again, then it's going to go ahead and work. So we can access the variables that we create in this first part of the if in the condition of our if statement. If we have an else here, and let's say we kept this n if n is not equal to 0, we can do something else. We can access the variables we assign in any of our conditions in our if, whether it be an if or an else if. So just a couple of interesting ways to make things a little bit shorter.
Another thing to know is that you can't use n after that.
Yes, that is a good thing to note. So n does not exist outside of the scope of this if statement. So if I try and use n down here, it doesn't exist. It is scoped entirely to the if statement. You can use it in the conditions. You can use it inside the actual code running in the if, but you cannot use it outside. Good call. Okay, so that works pretty well.
Is there a limit to the number of returns a function can return? Or is it just like
I don't know that there's a limit. I have never encountered a limit. At some point,
there should
what are you doing? And you should find a better way to do things.
entire object for only return this?
Yeah, at some point, if you have too many things that you're returning, like you cannot even read it, it goes so far off the screen that you have to like scroll to figure out what it's all returning, and it's just kind of a nightmare. But generally, like if you have 2 or 3 things that are related that are helpful to return, you can do that. Whereas a lot of times from what I've come across in C, you kind of like pass in a pointer reference to a variable, and then you like modify it there so that the code that calls it can then use the updated value, because you can't return multiple things. Well, here you can do that. So you can just go ahead and pass in whatever you want. You don't have to pass in something you want technically as a return value. You can create things and then pass back as much as you want.
The underscore thing, if like let's say a function returns 3 values and you set 2 of them to be underscores to basically say effectively they're ignored. Like, does the compiler allow you to do that, or is that just like
You can underscore as many things as you want. I would be surprised if it prevented me from, oh, it does prevent me from underscoring everything. Compiler doesn't like if there's no new variables on the left side. So in this case, our underscore means we're not using anything. So like it's trying to tell us, dude, what are you doing? Why are you doing this? But another thing that we could do here is if we already had, so let's say we're skipping the n, and this is not a good piece of code to demonstrate this. But let's say that we already have our fill assigned here, and we try and reassign using our colon syntax again. And we had try and assign this TED instead. It's going to give us the underline saying no new variables on the left side again. So this is like an initializer. If you're just going to reassign to a variable, it's just normal equal sign. But if you're going to initialize, that's when you can use a colon to spare out on the var in the string. So this is the same case where there's no new variables on the left side. This thing already exists, and so it's not going to let you do. I know this is another interesting thing, I guess. Let's try this. Apparently not. No, it is a thing. So you can, the way of doing this in Java would be like int I is equal to 0, j is equal to 0, blah, blah, blah. And I wonder if you can actually do that here as well. It does not like it. What if I did Bob instead?
they wanted a semicolon after the comma instead of like
Yeah, so it's not going to like the same syntax either, any way that we do it. So the way of doing it here would be we can declare our new things, and all of our things that we want to assign on the left, all the things we're going to assign to it on the right, which again is very counterintuitive. I find that over the summer when I was doing this, I would go home and write like some JavaScript, And then I would just be doing all of the Golang things and none of it would work. And then I would go back to work the next day. I'd try and do all the JavaScript things and none of it would work. And it was very frustrating. So this does work. We're not using high. That's why the red squiggly happens here. But you'll notice that the no unused variables things goes away because now there is.
You make high underscore?
No. No new variables on the left side, but this is a new variable. And so we can go ahead and use this. And in this case, Phil actually will be reassigned here to be something new. We could call this Ted. Run this. Cool. So it worked. We printed out Bob and Ted because we reassigned Phil here. So you'll notice that Phil originally was the string Phil, and then when we used our initialization operator, it just reassigned for this one and for this it initialized. As long as there is something on the left being initialized, the colon operator is required. Otherwise, it would just be a normal assignment, which doesn't work here because high doesn't exist. Okay, so a lot to wrap your brains around, but we're gonna go ahead and keep moving on here. And as we go ahead and create our actual project at the end, we'll kind of recover some of this in like actually meaningful scenarios, because right now this is not super important. All right, I'm going to go ahead and take all of this out and we're going to move on to the next topic. And the next topic is going to be looping. Looping is also weird. You should get used to things being weird here. We have a question. What does your go.mod and top of your main.go look like? This is all that's in main.go. We declare our main package at the top, import anything we need, and then we have our main function. Go mod should be blank. We have not installed anything new. We'll do that at some point. But right now it should just tell you the version and the module. Okay, so we're going to cover looping. The first thing we're going to do is we're going to do a very basic for loop like you would find in any other language. And that is okay with Go, except for the no parentheses thing. We can format .println I. The type is inferred anytime you use this colon operator. So this does not like it because we can't concatenate things randomly like Java. This is an integer, this is a string. So the other thing we can do here is we can use our printf, and we'll %d, which stands for the integer code, and then space afterwards, and then we'll throw in I here. And we'll go ahead and reopen the terminal. And we can print 0 through 9 as you would expect. Okay, so that works. You might expect, well, this looks normal. Maybe a while loop is also normal. It is not. While loop does not exist in Golang. It simply does not exist. Instead, what we do is we use a for loop and we only use the condition in the middle. So we could say out here, I is equal to 0 because I is scoped inside the for loop, so it doesn't exist over here. And for I is less than 10, format.printf %d space I plus plus. And this works exactly the same. So essentially what we're doing is we're leaving out any of the initialization or the post update of the for loop. So this stuff over here, and the while loop is just the stuff in the middle. This also does work in Java. Like if you were in Java, essentially what you would do is you would do for just a colon, meaning that there's nothing in front, I is less than 10, and then another colon, and then nothing afterwards. And this looks really, really weird, like you would just use a while loop at this point. But this is essentially what's translating into Golang, except without the semicolons and without the parentheses. Okay, so that's cool. What else should we cover right now? We should cover an infinite loop. So let's set I back to 0. We'll do an infinite loop, which is literally just the word for. You don't have to put a like for true. You could if you want to, it would do the same thing. But just for is an infinite loop, and we'll go ahead and copy this out here. We'll print whatever I is and increment it. And then when if I is equal to 10, this is not going to be symmetric with the other ones, but we'll just leave it. We'll go ahead and break. And then we'll print a new line at the bottom, as we've done previously. So when it's 10, it'll go ahead and break, but otherwise it'll run infinitely. Some of you might be screaming internally, why would you use curly braces if it's only one line? That's disgusting. Don't do that. It is required with an if statement to use curly braces no matter how long your if is. If it's just one line,
Wait,
sucks to be you.
There's no ternary. There's no one-line ifs.
Correct.
Why?
I'm asking myself the same question. Someone very smart has decided that this is not necessary. I was not that person. So this does actually come up a decent amount. The general way of handling errors is you make a call to a function, take the things back, it'll give you back an error. You check if it's nil. If it is nil, you go ahead and return out of the function you're currently in and tell them that it was an error. And the way that that kind of looks is like, let's create a basic function here. Test, and we'll go ahead and return two things. The way that we return multiple things is we have to put it in parentheses here. So we can say the first thing we're going to return is an int, and the second thing we're going to return is an error type. And we're just going to return the error every time, just because this is really fast. The way we're going to do that is with format.errorf, and then we can go ahead and create our error string. And
what's the type of error in that return? Is it just...
Error is the type.
Oh.
Error is the way that you return everything. It literally is just a wrapper for a string, more or less. And so we are using the format to send back our error string. And we also have to send back an error and an integer every time. So we can go ahead and send some dummy value in the integer, because really, what we're sending back is we're sending back the error, and someone's going to check, is that error equal to null or not? They don't care about the other thing if we do have an error. So we can send back whatever we want. Let's, for the sake of demonstration, let's send it a value x. And again, data types are after the variable declaration. I don't know why. It drives me up the wall. But let's say if x is greater than 10, we'll go ahead and return x, and then we'll return nil for the error, which means there's no error in this case. Otherwise, too low. We'll change the error here. And you might be asking, well, I guess we can actually maybe make this faster. Let's try and do, oh, but we can't do a ternary. Yeah, we could do this in one line. We could just return the condition if we had a ternary operator, but we don't have a ternary operator. So we have this disgusting mess instead. Yeah, so let's go ahead and use this test function here just to show you what the general strategy for handling errors is. Let's say we want to test the value 7, and it sends back two things. We don't have to assign it everything. It's totally fine if we don't assign it anywhere. But let's say we're going to assign it to a value x here, and then error, which error has been declared further. Nope, I got rid of it. Never mind. So these are both new variables here. And again, it's going to infer the type. So x is going to be an integer and this is going to be an error type. If error is not equal to nil, which means we do have an error back, then we're going to return the error ourselves. Otherwise, then we can go ahead and do stuff down here. This is kind of the pattern of handling errors. So you're going to call your function, you're going to check if there's an error. If so, you're going to return that same error back all the way up the tree of function calls. Or you're going to do something else with it, whatever you want. And then you're going to go on your merry way afterwards, which is, I personally think it's verbose, but it is generally how things work. And so a lot of the stuff that I was writing this summer, the top of the functions was really just let's call 7 things and return an error for all of them and then do the main code at the bottom. You get used to it after a while. Okay. So that's in here. This is not actually going to run just because the main function doesn't return an error. So I'm going to go ahead and get rid of all of this here. What else do we have on here?
Does it automatically remove exports that you don't use? So I just hit save and just deleted FMT.
So when you save, at least with VS Code, it runs go mod tidy, I think is the command, which Go like has its own formatter that it will go ahead and run for you, along with its own compiler that basically like forces you to write Go the exact same way. Like, you know, there's some stylistic decisions in some languages, but Go decides style is out the wazoo. So it probably does do that for you automatically. Okay, so this is cool. I'm going to go ahead and get rid of all of this stuff in here. We're going to move on to the next topic. And the next topic is we're going to talk about arrays and slices. Slice is not something you've probably heard before, but they are very, very interrelated. So essentially, an array and a slice are the same thing, except the slice grows and an array does not. An array is a fixed length. You cannot make it bigger no matter how hard you try. You cannot reallocate it. It is a fixed length. You can put stuff in it and treat it like a normal array. But if you want something that you can append items to, or you can grow sort of a la array list in Java, then you have to use a slice.
So like in arrays in general, you can never update arrays or just.
You can put stuff in the array and like take stuff out, but it will always be length of 10. You cannot make it larger or smaller no matter how hard you try. And there's some different syntax to specify which one is which until you've done it a little bit is actually sort of confusing. And if you go on Stack Overflow, there's so many questions of people that just don't know the difference. So a slice, essentially, we're going to declare with our curly brackets and then the type of the slice. And an array, we're going to declare with curly brackets, but give it a size. That's the difference. Why the brackets are in front, who knows? Someone very smart has decided that this is the way to write a program. Yes, that would be nice. So let's do a couple of interesting things here. Let's create a function down here, create 5 or int array. And we'll go ahead and specify a length and we'll also specify a default val int. Someone said O.
I caught on the reversing the data type as well.
Yes, it does take some getting used to. And we are going to return from this our integer array. But if we don't put a number in here, it's going to return a slice. And when we don't return a slice, it's going to have a problem. And so we're going to specify that it will be exactly of length 5 every time. And so that's fine. If you have one return type, it doesn't have to be in parentheses. If you have multiple, then it has to be in parentheses.
Are there helper methods that let you convert between the two? Like you can in Java take an array list dot to array and then change to an array.
I don't know. Generally, because it's like, I have no idea. I've never personally come across a scenario where I would want an array. And so I haven't had to convert it at any point. I would assume there's something, but that would be a good thing to research at some point. So the way that we're going to do this is we're going to declare our array here. And we're going to initialize it. And we can do this 2 ways. We can specify our thing here. Sorry, there's 2 ways for a slice, but I think this is the most concise way to declare an array. So we need to give it how long it's going to be, the type it's going to be, and then we can go ahead and put curly braces on the end here, which means you can start to put stuff in there if you want to. So we could put a 1, a 2, a 3, a 4, and a 5. And let's see if we put more, if it's going to have a problem. Yes, it is. It is out of bounds. It has to be 5. Golang does catch a lot of things for you. That is really nice. Some of the weird syntactical things bug me, but the compiler is incredibly helpful. Maybe not as helpful as Rust, but it's pretty helpful. Okay, so this works. We can also, I think, create an array using the make keyword. And the make keyword just like goes ahead and allocates memory for things and then gives it back to you. So let's try this. Does this also work? No, you cannot make an array. You can only make a slice, a map, or a channel, which we'll talk about a map after this and a slice. We will leave out on channels because channels is far too much to cover today. Okay, so we have our integer array here. We can go ahead and treat this like a normal array. We can update a value in here. We'll update the third one to be -1 instead. Fourth. That's a good call. And we can go ahead and return our array here. So this works. This is something basic we're doing here. Let's say that this method is, or this function is specifically going to initialize this. And we want it to initialize it to a certain length. And we want it to have all default value inside. So like Java would normally put a 0 in for all of your integers. Let's say we want to specify something unique. So you might think that we could do this. But we can't do this. Because length is not a constant value. So we could put like a number in here. We could put something that's literally constant, but we cannot put a variable in here to tell it how big our array is going to be. I also don't know why this is. It seems like it would be useful. But basically, anytime that you have a variable and you want that to be the length, you just need to use a slice instead. Okay, so we're going to go ahead and just say that this is 5, and we'll go ahead and take the length out of here because we can't do anything with that. And then we'll go ahead and use our for loop. So we will go from I is equal to 0, I is less than 5, I plus plus, and we'll say array of I is equal to default val. And just to be fancy here, let's say that we only want our default value to be greater than 0. So what we can do here is we can go ahead and add an error to our return. And we'll check first at the very top, just to be safe. If default val is less than 0, then we will return format.errorf default value. And we still have to return something for this array. We cannot return nil because nil is only for things that have a reference. And an array is not a reference type, it is a value type. The difference here is that when we reference a value and we try and pass it somewhere, that thing is going to be copied in for that function call. It's not going to have the original copy. If you do stuff to it, it's not going to be updated. Whereas if we pass in a reference, that's going to tell you where specifically the thing you're passing it is located in memory. And then when you edit that reference, it'll go ahead and change everything inside. So an array, we could pass in an array, it would just copy it every time. If that array is really big, that kind of sucks. So we don't want to do that in that case. A slice is a reference type. I'm going to tell you, like, I personally just have not used an array on my job this whole summer, like even once. Basically, everything is just a slice. Warren, you might be able to find a good opportunity to use an array. I have no idea. But I personally have not used an array for anything. So a slice is generally going to be way more helpful for everything. You also had a question?
Yeah, I was just going to ask, like, what kind of situation would you like use a slice over an array?
Basically every situation.
Okay.
Like it works exactly like an array. It is easier to work with because it's passed by reference. It changes, you can append to it.
It's literally just the difference of like vectors and like arrays. With like vectors, like yes, like in the backend somewhere, someone's making some magical assumption of what you want to do in the reallocating it for you. But it seems like it's just like, no, just do it this way. It's easier. It'll be easier on you. It's easier on me to do it.
Go makes a lot of decisions like that. They know what's better for you, regardless of whether you know it or not.
The Go developers think they know what's better for you.
They really do.
They all like the questions to like why there's a way a certain way. Like so many people asked it and they've answered it. They actually like
There's a website where I just found it. It's
Yeah.
called Why Is It Not Here? And then they go through all the things that aren't there.
Yeah.
And
Yeah.
like a ternary, why is it not here? Simple design choice. We thought beginners
Yeah.
would not like ternary
A
operators.
lot of it's stylistic decisions, especially with like the curly braces being required for statements and stuff like that. It's for like legibility. Like even if you look at Google's Java, like their syntax that they use, they require.
Yeah, styling guides are fun.
It was like built because like they want to build like what Google already has and try to make it as similar as possible stylistically.
Yeah, there's a lot of that. So instead what we're going to do here, because we can't return nil because this is a value type, not a reference type, we literally just have to return an empty copy of an array. And they will just figure out what to do with it at that point. Because we're returning an error, it should go unused. That would be the correct way of doing things. Okay, so that works. And now that we have specified an error in here, when we return our successful version, we also have to return two things. And an error can be nil. And so we're going to return nil. So if we went ahead and did this, let's go ahead and assign create int array, and we'll say everything needs to be 10 by default. And we'll take our error in here as well.
So this is 9x.
This is 9x. You're in the right place. So we'll go ahead and print both of these just to show you what happens. We'll go ahead and go run. And it'll go ahead and print our array. Everything is 10. And then our error is nil. We can handle the error if we want to. Personally, I do not have the bandwidth to do that right now. So let's go ahead and do the exact same thing with the slice, just to show you that it's a little bit easier. And there's some different ways of handling things here. So let's take all of this out. I don't know why I copied this. Create int slice. And we can actually throw in our variable length here now, which is great. And we can pass back just a slice, which doesn't have to be of any particular length. So we can take the length requirement out. And we're going to do the same thing. Let's do some extra error checking here. If length is less than 0, we'll return format.prints, or sorry, error f. Length must be positive. And I'm not going to handle the default value less than 0 because that was arbitrary. We'll say that it's okay here. And again, because the slice is a reference type, you can return nil for that. So you don't have to like make a new slice just to return it and then it never be used. Okay, so we've done that. We can now go ahead and create our thing here. So we have a little bit more flexibility in how to create our slice. We do the exact same syntax here, except without providing a length. One other thing that we can do is we can use the make keyword, which is used for slices, maps, and channels. We'll do maps right after this. And what we're making is we need to specify what we want to make. We want to make an integer slice. Does it not like this? Expects 2 or 3 arguments. Okay, that's what I was expecting. And then after that, you can specify how long you want it to be. Because we're making a variable length thing, we don't want to just declare it like this. We could append default value length times to this. That would totally work. But we can also just create it and it's already at the length that we want and we don't have to constantly reallocate it. Okay, so this works. We'll rename this to array. And then let's do for I equal to 0, I is less than length, I plus plus, array of I is equal to default val. And then we can go ahead and return our array and nil. And I'm just realizing I'm calling it an array, but it's not an array. So just to be 100% correct, we'll call it slice instead. Okay, so this should also theoretically work. Let's go ahead up here and copy this and we'll create our int slice instead. And we'll create it of length 3 and everything can start as -1. I'll call this slice here. If you don't rename this, then it's going to give you the big error of no new variables on the left side, since array and error already exist. Let's go ahead and run this. And it works. It creates a slice of length 3, and they all start as -1. So with the array, all we can really do is put stuff in and take stuff out. Great. With the slice, we can go ahead and make it a little bit larger. We can do some other interesting things here. Let's say we want to add another value on the end here. We can go ahead and append to that. And if you were using Java, you might be able to have your list here and then call list.add, which would be, a pretty normal way of doing that. That does not exist as a function of slices. So instead, what we have to do is we have to reassign the appended result of slice and our new thing. So we are taking slice, we are appending 8, it returns a new slice, and we put it back into our other variable. And we can go ahead and print that now and run this. And it goes ahead and works. Again, doesn't really, look normal, but that's the way that we do it. And there's a couple of other interesting things we can do here. We can call len, which gets the length of your slice. This kind of looks like Python more than anything. We can run this, and it's of length 4. All right, that is everything with regards to slices and arrays for now. How much time do we have? Okay, we have until 8. Show of hands, how many of you guys are gonna have to leave before 8? 2. Okay, I'm going to go ahead and cover structs and methods, which I don't know how long this is gonna take, just to be complete, and then we'll move on to the actual server stuff after that. I'm hoping that we can get this done in like 20-ish minutes and then have the last 40 for the actual server part. Okay, so with that being said, we'll go ahead and take out all this code again. And there are no objects per se, like there would be in Java and Golang. Instead, Golang functions entirely with structs, which will look very normal to you based on what happens at C. The way that we can define a struct is by using the type keyword, and then we'll call it whatever we want. We'll call this person. And then we need the struct keyword to tell it that we are defining the person to be a struct.
Where is this being deployed? Like, who uses Go? Like, is it a backend? Is it low level? Is it what?
It is almost entirely a backend language for creating whatever backend service you want. And we're going to do a little bit of that at the very end. As far as I know, I don't think there are any like Go graphics libraries or anything. I don't think that's really the use case. There might be something, I have no idea. But it is primarily used for backend technologies. And we'll do that. So we're going to create our struct here, and we can define whatever properties we want in there. We can say that this person has a first name, which is a string, and they can have a last name, which is also a string. And we'll give them a nickname, which is also a string. Sorry, I want to make something that's a different type. We'll give them an age as well. Okay, so we can go ahead and create a person here. P1 is equal to person, and then curly braces to specify that we're initializing it. And we can leave it here. All of these things will be initialized to their default value. Let's do format.println here, P1, just to show you. Everything will be initialized to default values, which is an empty string or 0, hence the reason why we don't see anything, and then we see a 0. Or we can pass in as many things as we want to initialize as we want. So let's say we want to give them a first name is equal to Eli. We'll give them a last name, Smith, and then we'll give them an age, which is 21, in case you were curious. And we'll go ahead and print this, and everything will print as we expect. We could leave some of this out. We don't have to give them an age if we don't want to. That'll be 0. We'll go ahead and give an age just for now. So this is your value of a person. Let's show you what the value, what the point is here. Okay, let's demonstrate this with a separate function. Person. I already started writing the type before the name, like a normal person would do. And we'll new age is an integer. And we will go ahead and just leave this out here. So let's say we want to update person with P1, and we'll set their age to 50. Format.println P1. And in here, we will take person dot age is equal to new age. And let's see what this does. You'll notice that when we print it out here, it does not actually update anything because again, we're passing it as a value. This is a person struct. It's not a reference to the struct. And as a result, it's going to copy in the person. So this person that we have in update person is not the same instance of the struct as P1 up here. So anything we make doesn't get updated. The way that we can change that is we could pass in a reference by using the ampersand. And we can take in here a pointer to a person using the asterisk. And now if we go ahead and do this, it'll go ahead and update. And you might remember in C that when you have a pointer, you have to do the weird arrow thing rather than the dot. Golang just lets you use the dot in every case. You don't ever have to write one of those weird arrows or figure out, how am I going to, reference and dereference and do all kinds of weird stuff. Golang will just handle it for you, which is one very nice thing about Golang. Okay, so we can also store a reference by when we're initializing it using the ampersand up here. And so now P1 is a reference and we can delete the ampersand and we'll pass in a reference directly. So this is really cool. What if we want this person to introduce themselves? Like this is a classic, like make a method for your object where they like say, hi, my name is blank. You cannot create a method that is directly in the struct. The struct is only for variables, which is the same thing as in C, I'm pretty sure. And the way that we do this instead, one thing that you could do and would be totally fine is you could create your say hi and then pass in a person here and then have them say, hey, my name is whatever. But let's demonstrate a different way of doing this. Let's say we want to have a function that is implicitly related to one type of struct and should not be used by anyone else. So what we can do here is we can declare our function, say hi, and this will be a void function as well. And instead of passing in the person in here as an argument, we are going to say that this is a function of the person struct, which means if we have a person, format.println, hi, my name is p dot first name plus p dot last name. So now what we can do is instead of calling your update down here, we can literally use P1 and then call say hi off of that. And because this is a value type, and this is also a value type, we can use our P1 value type to call this. We run this. It'll work, no problem. Let's say that we have a reference here instead. And let's try and run this. Oh, this actually works. I was not expecting this to work. I think what this is doing is it's going to go ahead and dereference this for us. I think it will cause an error if we do this. Maybe. All right, Golang is too smart for me. Never mind. So what I was going to say here is that you can also assign it to the type reference to a person, which means only person references can call this, which burned me a couple of times over the summer. It is not burning me here, so I'm honestly not sure exactly why it's not causing an error. I'm hoping that we won't run into it in the future, but this is something to be aware of. So this is specifically related to the person, a reference to a person. Okay, that's structs and methods. One other thing to mention with structs here is that there are no public and private modifiers. If you have a member variable in a struct, if it is lowercase, it is private. If it is uppercase, it is public within the module. So if you import this to another module, anything that uses your person will not have access to any of these three things because they're lowercase, which means that they're private. So instead what we can do, and I'm going to tell you a very short anecdote. I was doing a little bit of extra preparation for this workshop, and I was trying to come up with a couple of other routes that we could make for our server. And I did not capitalize all of the fields in the struct that I made, which was a contact struct. And as a result, when I was trying to return it as a JSON. It was coming up as an empty object. And the reason why is because the serializer looked at everything and said, this is private, I don't need to put it in here. And that took me at least 25 minutes to find a Stack Overflow telling me what my problem was. It does, it burns you a lot. It doesn't matter, like if you're working within your own module, you'll be able to access everything, no problem, but it does have a problem when you're going to a different module or you're passing it to someone else to use. Okay, so now that these are public, we'll have to update this first name. We'll have to update this last name. We can run this again. Nope. What did I do? Oh, I didn't update it further down here. Okay, and so now it works as we expect. Okay, I think this is everything that I wanted to cover in terms of basic syntax. There's a lot of weird stuff to know here. And we'll use some of it very quickly. But now we're going to jump into the actual part that you guys are here for to make a very simple project. We're going to create a very simple API server that you can run on your own computer. You can send requests to. And we're not going to go to the scope of like, how do I put this on a cloud somewhere so that other people can get to it? Or like, how do I make this secure with authentication or like middleware to try and, you know, catch stuff? There's all kinds of things that are really important that we're just not even going to cover because we're already at like, you know, 54 minutes left before we have to be out of here.
Most cloud providers have like student programs and you can get like 3 credits.
Yes, I ran out of my Azure credit at Shell Hacks a couple weeks ago, and I ended up having to pay 2 cents before I realized that that it ran out. So you can definitely get a lot of good stuff. That lasted me since the spring for a couple of projects. So it is a lot. Google has a lot. I would assume AWS has a lot. I haven't used it. Azure is my favorite just because it's really easy to set things up. Okay, so with this being said, we're going to go ahead and use a package. We're going to go and look for Gin Golang. We're going to open up this GitHub link that comes up at the top. Gin Gonic and Gin. I'm going to zoom in here. So Gin, you may or may not like this Gin. This Gin is a way of creating a server that's going to run and it's going to listen for HTTP requests and perform whatever you want, and then send back something in response. This is the basic pattern of how we create our API servers. We give it a bunch of routes specifying you can search at this particular URL and pass me in whatever data I need, and we will go ahead and do something with it and give you something back. Fundamentally clear what the general point of creating a route is. We can specify as many routes as we want. This is a design decision. You can figure out what you want your API to be able to do, what people have access to, and how you're going to structure all of your, all of your data. Are you going to put it in a database somewhere? Are you going to, use a bunch of funky algorithms? That's entirely up to the creator. We're going to not do anything very fancy here. So the way we're going to install this is we're going to use go get, and we're going to get it from the GitHub link. So I'm just literally going to copy and paste this in here. We're going to run go get -u github.com/gingonic/gin. And it's going to go ahead and take its time. It's going to download all kinds of other stuff. And eventually it'll work. Anyone having any like installation issues? I would hope not, given that it's exactly one thing to do, but we all know. Are we all good here? This is a great question. So I found an extension that I want to say is called Noctis. Noctis, yeah. And this particular one that I'm using is uva, which sounds very like in Spanish, grapes are uvas. And so like the purple kind of translates in my head. I'm sure that's not the reason why it's called uva, but it works in my head. This is my favorite by a large margin. I haven't changed it in a while. Okay, so we have our Gin installed here. And if we go, now we have a go.sum. And our go.sum is like an auto-generated thing of all of the dependencies that it needs to run and all the things that are installed. I would hope that you will not have to edit this hardly at all in your life. And if you look at the Go mod, we now are saying that we require all of these other packages that Gin needs, which is what we found in our terminal, and then Gin, Golang, Gin. So we could use any of these now. These are all installed in our module. We're only going to use Gin. Gin is going to use everything else in the background. So with this being said, we are going to initialize a new variable here, and we are going to use Gin, which will hopefully auto import for you. And we're going to use gin.default, which is going to create us a very basic engine with no like special things that we've configured. It's just very vanilla, everything that we need to work, and it's going to give us back our thing here. In a lot of languages, you might be using like a router object in JavaScript, and then you attach the routes onto there, which is why I'm calling it R. It's sort of the same thing. And eventually at the bottom, what we want to do is we want to call, I think it's start. Nope, it's not start. App engine canvas. Routes run, I think is what we want here. So we're going to run this, and we can go ahead and open our terminal. And we will once again go run main.go. And hopefully what should happen is it'll take a little bit to actually get everything started, and then it'll give you this long output telling you that the engine was created, it's running in debug mode, and it'll tell you that it's running on port 8080 by default. And the way that we can test this out is if we go into a browser, we go to http://localhost 8080. Go in here. It's not going to like anything here because we haven't defined any routes for it to reach. This is still not what I was expecting to get, but I think that it will hopefully get better once we have an actual route in here. So we're going to leave that for now. And what we're going to do is we're going to create our very first server route. And we're going to make something very basic. We're going to do a ping pong route where you send in ping and it sends you back pong and it tells you how long it took. We can't actually do the, I'm sure there's some way to track how long the request took, but we're not going to do that here. So what we're going to do here is we're going to use our engine, and then we're going to specify which HTTP, what type of request we want to accept. And we're going to have this be a get. There's a couple of ones that you will use most commonly. Get means that I'm looking for something that you already have on your server and I want to have it back. It's like not modifying anything. You're not sending something new. You're just getting something. There is a post, which means that you're creating a new resource. There is a put and a patch, which both are related to editing. Off the top of my head, I believe that put means that it's going to completely update something that already exists, whereas patch means it might only update like a couple fields of something. And then also delete gets used pretty often as well. And basically, you just want to decide what is this route going to do, and then pick the request type that makes the most sense. We're going to use a get here. And the first argument is on their URL, where do we want them to go in order to access this route? So we'll call this route /ping. And we can extract our function, but because this is really simple, we're not going to do anything crazy. VS Code has already done this for me helpfully. But essentially what we need to do here is we need to provide a reference to a function that will be called when we go to this route. If you used JavaScript before, you can very easily assign a reference to a function to a variable. You can do the exact same thing in Golang. When we declare our function, it returns a reference. We could put it into a variable if we want to. So this works, and it holds a reference to a function. So we can go ahead and do this, and then we can declare inline. We'll go ahead and declare this one inline, and the rest we will not. And what we want to do is we want to send something back to the user who sends this request. So we're going to use this context here. We're going to call context.json, which sends back a JSON. And then we are going to send back, it wants two things. The first thing it wants is a code. When we send a response, we want to send a numeric code, which tells exactly what happened on our end. We'll give them more information if there's an error, but the code is just like a general, did things work? Or in what way did they not? So there's codes for, we're going to actually import the HTTP module here. I don't think we have to install. Yeah. Oh, maybe we do. We'll go get HTTP. Oh, never mind. What did I do here? I don't remember having to install it before. Oh, yeah. Does this work? Yeah, okay. That's a good call out. Thank you. I appreciate it. So we're going to import net/HTTP here. And what this does is it provides us sort of like an English version of all of the codes so that we don't have to go crawling through Wikipedia to figure out what does a 401 mean? What does a 402 mean? Instead, what we're going to do here is we're going to call http.status OK, which just means, yeah, sure. And then we can return literally anything we want here. We're going to return a string in this case, which is just Pong. And this returns nothing, but the function ends, so there's no problem here. And we can go ahead and run it. If your server is still currently running, go ahead and Control-C to stop it. And then we'll go ahead and go run main.go again. And eventually it'll start. And what we're going to use to test this is we're going to use the command line utility curl. You can also do some of this through your browser, but for post requests, it's a lot more difficult. Forget, you just like put in the URL you want. But I'm going to go ahead and use curl. If you have a Linux or a Mac machine, you can do it through the terminal, no problem. I think on Windows, you have to do it through PowerShell, is what I was reading. Using curl. I think it should be installed on Windows by default. It's on PowerShell. So make sure you open PowerShell and not just the normal terminal. So I'm going to go ahead and open a new terminal in VS Code here. And if we curl, it's going to tell us we can do all kinds of other things. But essentially what this is this is just like sending a request to a particular URL, and we can pass in data, we can pass in whatever we want in order to make this work. And right now, we're not passing anything in here. All we need to do is go to the particular route where our thing exists. And because we're running this locally, it is always going to run on localhost. If we hosted this somewhere in the cloud, that URL would be like an actual URL. And we need to specify with a colon that we are going to specify a port. And you'll notice if we go back in here, it's saying that it's going to serve on 8080. So we're going to specify port 8080. And we'll call our route. Our route is just tacked on at the end of the 8080. So we'll do /ping. And it gives us back Pong as a string. You made your first GET request. Congratulations. Cool.
Oh, the terminal gives you the time response as well. When you're looking at the one that actually has the server running.
Oh, yeah.
It should show like what request, what route, and the time to respond.
Yeah, that's a good call out. So this is all information about the request that we sent. We sent exactly 2 ping requests, and both of them are logged in here. If there's an error that crashes your server, it will also be in there. So like if you send a request and you don't get anything back, which I did a bunch of times this morning, I forgot that I have to actually check the server, and there were a bunch of very disgusting red text coming back at me. Yes. So one thing that we can do with our curl is we can specify a flag. So if we curl and then put -v on there, it's going to give us the verbose output, which basically just has all of the things you could possibly want to know about your request and everything that comes back. So it has, headers about like what kind of content did we send back? What was the status code? We sent back an OK status, which corresponds to 200. Where did we send it? That kind of thing. Cool. So how much time do we have? 40 minutes. All right, I have 2 versions of things to create here. The first one was the original plan, and I thought it would be Mimi to make a contact manager because Lineker in his Post class makes everyone do a contact manager. But that one might take a little bit longer. And the other one is just sort of like a random number generator. where you can send up a new seed and do stuff like that. Does anyone have any preference? Show of hands for contact manager. Okay, we're not doing the contact manager. All right. All right. Some people are very emotionally scarred by the contact manager.
Let me go 2 years without looking at it. Thanks.
Yes. Eventually, when you have line of code for Poots, it'll come back and haunt you. Okay. Also, I just realized that we have our ops meeting at 8. God, okay, so I'm definitely going to have to end a little bit early. Okay, so let's do this a little simpler. Let's go ahead and create a new file here of routes.go. So this is still within the same package. So we're going to go ahead and put our package main at the top here. We cannot declare a new main function since main was already declared in this block, which is this whole module that we've created. But essentially, we're just going to put some extra functions in here, and then we're going to call them from this other thing. So let's specify what we want to make here. So we want to make probably a get request to just like generate me a new random number. And let's say that we could pass in how many numbers do I want back. And the other thing with pseudo random numbers is that they're all generated based on a seed. So the seed goes in, and then if you generate numbers after that, every time you reset with that same seed, it'll generate the exact same sequence of numbers. So let's also create a seed that's running on our server, and we can make maybe like I don't know, we could make a patch request just to update the seed, just to make it interesting. Trying to think of other things. We'll make some other things as we go. Let's start with those two. So we're going to declare some new routes here first, then we'll implement them later. First thing is we're going to do our get, which is get me a bunch of new random numbers, and we'll do this /generate will be our route. And we also want to pass in the number of numbers that we want to generate, which we will do shortly. And because we want to reference to a function, let's create a function in here really quick, generate numbers. And again, we need to have access to the gin stuff so that we can send back a request. So this comes from a pointer to gin.context. And generate numbers now is a function that exists, and we can go ahead and use the reference to that function as what our get is going to run. Notice there are no parentheses here. If we put parentheses, it's going to try and execute it right here. And it's a void type that comes back, which means you can't use the void as a function. So just make sure that this is just the name of the function. So it gives you just a reference. Okay, so we have that. Let's also create a patch request here. And we'll patch the seed, update seed. We'll create something for that, func update seed. All right, so we have this up here. Let's go ahead and create a global variable here. This is probably not, like if you were storing something more important here, you probably want to use a database. But this seed, like it's just going to get reinitialized every time we rerun the server. So if the server crashes, if it closes, it's going to restart with the same thing. It will not be persistent if we update it, but we're okay with that for this case. So you might think that we can do this. We cannot do this. If it is outside of a function, we need to be declaring a type. So we could declare Bob, and now anytime we want to create an integer, we can say, let's create a new Bob. This works. You're basically you're defining a new type. That's what you can do outside of a function. In this case, we don't want to do that. We want to create a global variable. And so we have to use our var keyword. Seed 150. The seeds in Golang are all numbers. They're all integers. So we can just change the integer value. Cool. So now that we have our get request here, let's do a couple things. First thing we're going to do is we're going to get a parameter that we pass in called a query parameter. And the query parameter is going to be part of the URL. And that is going to tell us what the user is sending in, how many they want to get back. So we're going to get c dot carry. And the key that we're looking for in the URL is the count. If you hover over this, it's going to tell us, it's going to look for the key in the query value. And if it doesn't exist, it's going to return an empty string. So this doesn't handle an error with an error object. It just gives you back an empty string. But we still want to make sure that they actually pass something in here. And let's say that we're going to scream at them if they don't. Count is equal to an empty string. Then we will go ahead and return early. We'll send back some JSON. And in this case, we'll send them back a status bad request because they sent us something not okay. And we will send them the string, I don't know, count must be let's see, count variable. And so this is a void thing that comes back here. There's no return type, so we need to officially return from our route so that it knows not to execute anything else. And now that we have this, this is a string. Every single thing that comes in will be a string, unless we explicitly tell it to be something else. We can convert it into whatever we want. We're going to convert this into an int. Let's actually call this count string. That way we can call this count. It's not like Python where you can reinitialize something and change its type. If you declare a variable as one type, it is that type forever, regardless of whether you use.
More garbage collection to like unallocate and then.
I have no idea. Have not tried it. So we're going to go ahead and do this, and we're going to use the strconv string conversion module, which will auto import it here. If you have to manually type it in, that's what it is. And again, compiler tells me we're not using it yet. We're going to call it a toy, ATOI. I don't actually know what this stands for, but this is parsing the integer into just an integer type. There are three integer types. There's an int 32, and an int 64. An int type is a lot more flexible than either of the other two. So generally, if you can leave things as ints, probably a good idea to do so, unless you really need int 64 all the time. But you cannot like pretend that an int 64 is an int and like multiply them together. It will not let you do that. So we're going to use ATOI, which just returns a normal int, and we're going to pass it in our count string and tell it parse that. And it also returns an error, which we will collect. If error is not equal to nil, which means that something came back, then we also want to return early here. And we'll say this is also a bad request, but in this case, what we want is count must be a int. And let's handle two errors here at the same time. Let's also handle if count comes back and it's less than 0. We can't give them negative numbers, a negative number of numbers. So we'll handle both of these at the same time. And we'll go ahead and return out of that. So if the error is present, we'll go ahead and break out. Otherwise, if the error is not present, but our count is something invalid, we'll also break out. And count will just return some garbage default value that normally we wouldn't care about. If error is present, it'll probably be 0 for an integer if I had to guess, but we don't care in that case. Cool. So we've done this. Now let's go ahead and create our new things. Let us use the rand module. And first, let's create a, I don't know, just to prove that it's, I guess, maybe kind of useful. Is we'll go ahead and create, we can't even create an array. You know why? Because count is a variable. And even though count is not going to change into this function because it's variable, we cannot create an array. So we have to create a slice here. And we will go ahead and do that by the make keyword, and we'll create a slice of integers of length count. We'll do for I 0, I is less than count, I plus. Slice of I will be equal to rand, dot int. No, this isn't it. What did I? Okay, I don't think this is right. Hold on, let me double check. Should be way more options here. Hold on. There should be more options provided to me. That is the right package. We're going to go ahead and manually import this at math/rand. And we'll do rand dot. Why isn't it letting me do this? By package rand. But it's not even going to let me do that. Like it's not declared by the package rand. What am I doing wrong? Oh, it automatically imported crypto/rand. So crypto rand is generating random numbers like for like security purposes. If you look on, there's a go by example website that has a page on random numbers, and they say that if you want to do anything secure, you absolutely have to use the crypto rand rather than the math rand, because math rand is not secure. I'm going to go ahead and take out crypto rand here, and we'll leave math/rand in here. And now we should be able to rand.int n. And so it's going to tell us that we can generate it within an interval from 0 to n. We don't actually want an interval. We just want to generate some random integer. So it'll generate anything. And now that we have our slice, let's go ahead and return everything that we have. And we're going to do that using c.json again. And here we'll say that this is an OK request. And we will return. We can return, I think we can just return the slice itself. Let's do that first, just so you can see what this does. And then let's do it a different way after this, just to prove a point. And so my server is running. I'm going to have to stop it and restart it because we've changed the code in our route. Oh. Main.go 8. Generate numbers. Oh, I knew that this was going to come up and I already forgot about it. So you'll notice that we're running main.go, which only includes the code in main.go. Even though they're in the same module, the code inside of routes.go is not included in this run. We can change this by doing go run period, which means take everything inside this local directory, and then it'll work. So cool. So now our server is running. We can go ahead and curl one more time. We'll curl generate here instead, since that's what we changed it to. And the default of curl is going to be a get request unless you give it some data. And so we'll generate. And it's going to tell us it's missing the count parameter. So we can give it our count parameter by doing this weird syntax. You make this smaller so it wraps around. After our route, if we want to give it a query parameter, we use a question mark, and then we can now specify a bunch of key value pairs. So count is equal to -1, let's say. It's not going to like this because now that we have query parameters on there, the question mark and the other stuff is going to mess with the terminal. So we're going to put that in quotes. And now count must be an int. This looks weird. It's an excellent question.
Do you have a custom terminal?
I didn't think so. I literally factory reset my Mac yesterday. So like something's weird here. It's the greater than symbol here. Yeah. The other thing that I was noticing as I was practicing this today is that every time it sends something back, it puts a % sign on the end, which I also don't know why it's doing that. But that is not part of the return. We're gonna leave it. It's a feature. You'll notice that it's still an error here, though. The error is that count must be an int greater than 0. We gave it -1. So let's go ahead and give it 5 instead, and it'll give us back an array of 5 very large random numbers. So by default, your integer random here is just unbounded, whereas in Java, math.random returns from 0 to 1, and then you do a bunch of math to make it whatever you want. You can do that here. there is a function that returns like a float from 0 to 1, and you can do the exact same thing if you want. Okay, so this works. Let's also return this a different way, just for fun. Let's use gin.h here. So gin.h is a struct, I guess, that someone has implemented. And it basically just makes a blank map. Oh, we didn't talk about maps. I forgot about maps. All right, we'll do 3-minute detour on maps. So a map is like a hash table or hash map, except without all the funky methods. It's a little bit simpler to work with, but it does the exact same thing. Stores a bunch of key value pairs. All right, let's go into main.go here and we'll do some mapping. So we want to make a map, we have to literally make it, make a keyword, and then we'll specify what kind of map we want it to be. And we want it to be a map of, why am I blanking on the syntax here? So what this is going to do is this is going to make a map where the keys are integers, and then the value is a integer slice. We can change this over here to be a string instead, so it's integer to string. We can call my map 0 is equal to Eli. We can get something back from a println 0. This will work. I'm going to swap this out for a second. So we'll go run. Oh, now it's not used. This. Okay, so we inserted to our map by passing it in a key and passing it a value, and then we can get the same way. An interesting thing you can do with Golang is you can, if we get something back, it also returns 2 things. So let's say we want to get the name. The second thing is essentially a Boolean about whether it's in the map or not. So you don't have to like, the Java way of doing it is like, does the map contain this thing? Okay, let me get it. Otherwise, let me put it in, and then, you know, it's a little bit verbose, but you can do this in one line here, my map 1. And we can combine this with an if statement. If we found it, then we'll format .println. And format .println. Run this, and it's not found because there's no key in there with a 1 yet. If we change this to a 0, now it works. Cool. So you can make this any type you want. There's a type in Golang which is just literally anything, and that is specified by an interface with curly brackets. So if we specify a map where it's an integer to this interface, we can put literally anything as the value of the map, and it will not yell at us. We can call map 1 is equal to 30, and this will totally work. Okay, so if you want to behave like Python, where you can do whatever the hell you want, you can do that. If you want to have some structure and order in your life, you can specify a specific type. Okay, quick detour on maps. We're going to use a map really quick. All right, so our route down here, we're going to return gin.h, which creates a map, but the map is string to an interface with curly brackets. So this map is going to have string values as the keys, and then you can put anything you want in the value, which is helpful for constructing JSON, which is a bunch of key value pairs. So it's just shortcut. You could, you know, make the map and then return the map, but that's just excessive. So let's say we want to return count here. Or we'll return the slice, which is the value. And let's say we want to return something else here. Awesome. Yes. All right, so now if we stop this, and run it again. Curl to, in quotes, cp 80/generate. It's equal to 5 this time. And it returns us our JSON object, which has two properties. The first one is "Are you awesome?" and the second one is the slice that we want. So if you want to return multiple things, you can do that. You just put them in a map like this. Cool. Let's go ahead and take this back out since we don't actually care about that. We'll pretend that we're making this a very serious API. So it'll return our slice. And then the other thing we want to do here is we want to be able to update the seed value when they send us a patch request. So what we're going to do here is we're going to specify, instead of a query parameter, we are going to actually, I don't know how to do this as a patch. So we're going to pretend this is a post instead. It might be the same thing for patch. I honestly don't know, but just for the sake of getting this done in about 5 minutes. So what we're going to do here is we're going to assign new seed the result of c.postForm. So postForm takes whatever data comes in, which is a bunch of key value pairs, and we can look for a specific key. We'll call this new seed. And if we hover over this again, it'll send us back an empty string if it can't find it. So let's just copy and paste our error handling from up here. And then we'll update this. So now we're just going to copy a new seed for everything. Convert it to an integer again. Okay, so new seed must be greater than 0 for it to work. The default seed for the random number generator is 0. So let's do a couple things here. Let's first, now that we have our new seed integer, let's update seed is equal to new seed int, and then we will go ahead and send them back a empty thing here. We'll say that it was accepted, meaning that what they sent to us was okay, and we accept their post request, and we will send them absolutely nothing. But it requires to have a second thing, so we're just gonna gen.h have an empty map. Cool. So this works too. Let's go ahead and test this before I say that it works. Stop the server, run it again. And this time we're going to curl, but we're going to specify a new flag here. And this flag is going to be all the data that we want to pass in. We want to pass in new seed. Let's set this to 20 now. It's currently set to, I think, 150. Yeah. So new seed, and then we can specify the route again. And notice we have multiple, we can actually, for the sake of proving a point, let's make these the exact same route, but different request methods. And we'll go ahead and stop this again. Now it's running. So if we send it in with data, curl is going to make this a post request without us having to do anything. If we send it, it's going to send us back nothing. It works, no problem. If we were to send it some data that was not correct, like maybe new seed doesn't have a value, then it's going to tell us it's missing the key because it's an empty string. If we take away our data, so we just don't pass it anything, we don't pass the -d flag, it's going to make a get, and now it's going to look for count instead, which we didn't give it. Another thing we can do to specify exactly which ones it's going to be is give it a capital X flag, and then we can call post, and it's going to make it a post, and we could do the same thing. If we make it a delete request, there is no delete request on this route, and so it's going to give us a 404 not found. So we can have multiple different routes on the same URL, as long as they're different methods. Let's prove that this worked. So let us curl Let's curl our get. So we're going to get count is equal to 2. We're going to get 2 numbers here. What did I do? Curl. What did I do? SSL routines. Oh, I accidentally made it HTTPS. HTTPS is the more secure version and requires a lot more setup and money. Cool. So we have 2 numbers here. And if we do it again, we get 2 new numbers. Let's go all the way up here and we'll make another post request with our new seed. And let's change this to 20. Because we just restarted our server, the seed that it was using was 1. Oh, the seed it was using was actually 0 because we didn't officially set.
Well, we didn't set seed in the code.
Yeah. Okay, we're going to do that. I'm going to go up here. And we're going to use rand. Hopefully, that's the right rand this time, math.rand. And we're going to set the seed to be whatever our global value of seed is. And 64. Again, int and int64 are not the same thing, so you can cast it to an int64. Cool. So now we're going to set the random seed at the very beginning. So now our seeds are going to be 150 when we boot up the server for the first time. So let's do that really quick. Hopefully this will be the last code we write. We'll run the server. Okay. So here's what we're going to do. We're going to first curl, get 2 numbers. We're going to curl again and get 2 new numbers. Then we're going to post. I'm going to go all the way back up to my post request that actually worked. And we're going to set the seed to 20, which will send us back an empty thing, which means that we know it worked. If we want to make sure that it worked, we can use the verbose flag and notice that we get back our 202 accepted, which means it worked. And now if we curl to get 2 new numbers again, so this starts with a 732 and an 880, whereas our first curls, basically, they're nowhere to be found. This is really messy. But these were the 2 curls that we made with the new seed that we had. So the first one started with 5855. So let's post one more time and let's go back to our 150 seed. And again, if we use the same seed, it should generate us the exact same sequence of numbers. And we'll get to first numbers for the first time, starts with 5489. And the 2 that correspond here are, nope, didn't work. Cool. What did I do? God, such an idiot. You're right. We took the new seed value and then proceeded to do absolutely jack shit with it. Okay. Run the server new. Clear this all out. Curl for the first time. Our numbers are 5855 and then something else. We post our new seed of 20 and it's verbose. And now we get 2 more, and the first things we get starts with a 152. So that is not the same as we have here. And we can post again, and we'll go back to our 150, which should hopefully give us the exact same numbers that we had originally, 5855. And that should correspond to this one right here. Okay, so we reset our seed, it works. We can update our seed every time we restart the server, it'll set it back to 150. So if this was something that needed to be persistent, you would definitely want to use some sort of database option. Cool. I'm glad that I didn't do the contact manager because it took us way too long to do very simple 2 routes. So that would not have been fun. Any questions that I can answer? That's everything I have for you guys. I have a lot of questions for the Go developers too. Join the club. Express is like a framework of JavaScript that allows you to do all these same things. Like Gin and Express are the same thing, more or less. Gin is like the Go code that has been organized to allow you to run like a service,
Right.
whereas Express is the same thing, but in JavaScript. And I'm sure there's stuff for a lot of other languages. Anything else? All right. Seeing nothing, and my phone telling me that Ops is starting in 10 minutes.
Make sure you post the link, the link tree, I think, activate it.
For what?
for the Ops meeting.
Right, I need to do that. Okay, I need to post that. One thing before you guys go, we're starting a data team, as you heard from the announcements, and so it'd be really helpful to have some feedback related to our workshops. So I created a form to put on the link tree. It says workshop feedback. It should be like the third one up there. When you get home, before you go home, please just fill that out really quickly. Just give us some data that we can pass on to our data team so we can practice. And also so I can, see how I did. Thank you for being here. I appreciate it. Have a good Thursday. Have a good weekend. And we'll see you later.